Hey guys, this is a little review on factoring quadratics. On this first problem, on the first two problems, we're taking it from factored form, which looks like this, where they are in two factors that are multiplying by each other. That's what it means. And standard form looks like this, where it's in that quadratic or polynomial form. So in this first, we are multiplying or distributing. So this first term, basically what we're doing is taking each term within it, so 2x is one of the terms, and multiplying it by 5x plus 3. And then we're taking 6 and multiplying it by 5x plus 3. This is the distributing. So we're taking 2x times 5x, and that gives us 10x squared. And then 2x times 3, because we can't forget to multiply it by everything within the parentheses. That gives us 6x. And then we'll take 6 times 5x and add that, so that gives us 30x. And then we'll take 6 times 3 and add that, and that gives us 18. And then with the two middle terms, since they both have just an x, you can add them together, so that gives you a 36x. And this is the standard form. So this is just a distribution. You can kind of explain what you think is going on there. The next one, different factored form. We have 3x plus 4 times 2x minus 5. This is called the area model, but it's basically doing the same thing. So each term, so 3x is a term, 4 is a term within the factor term, and then 2x and negative 5. Those are placed in the area model as on the side of it, on each side of it, and they're paired with the term that they are in the factored form with. Now, in each box, now we're going to take 3x times 2x, that gives us 6x squared. And then 4 times 2x gives you 8x. 3x times negative 5 gives you negative 15x. And 4 times negative 5 gives you negative 20. Now, moving on from there, we're going to take all of the things that are within the area model and add those together. So we get 6x squared plus 8x minus 15x minus 20. Since 8x and negative 15x are common terms, we can add those together to be negative 7x, and that gives you the full standard form. So kind of explain what's going on there in the area model. Okay, so using either method shown above, either do 5x times 3x minus 4 minus 9. Don't forget to distribute the whole negative 9. You can do it that way and get your standard form, or you can do it with an area model. Like it's shown above, 5x, and it doesn't matter which side each one goes on, as long as they stay on the same side as the term that they're in the parentheses with. And you can multiply those and add those together. In the end, you should get, let's see, 15x squared minus 27x minus 47x. And plus 36. Sorry about my dog. Okay, Minima, it's okay. You're fine. Okay, so just make sure you show the work on how you got there. So with these next few problems, we starting out with a standard form and we're going to the factored form. So I've put some blanks in here so that you can start to see some patterns of how we can get from the standard form to the factored form. And then hopefully by the end you see some of those patterns come about. So in this first one with 3x plus 10x minus 8x, I have split it up so that we have 3x squared. That's still equivalent to what it was before. Now we have 12x plus a blank minus 8. And so minus 8 is what it was before. But if I put a 12x in there, that means I'm going to have to do a minus 2x in order to balance it so that it's still that 10x that it was equivalent to before. Okay, now we're going to kind of group these first two terms together, 3x squared plus 12x. Those have in common a common factor, and that common factor is 3x. So we can divide both 3x squared plus 12x by 3x, and that leaves us with an x plus 4. If we do similarly to the next two terms, to negative 2x minus 8, those can both divide by something, and that would be a negative 2. So negative 2, taking that out of your second grouping of negative 2x minus 8, you'd be left with x plus 4. Now the goal here is to get it so that you have factors right here, x plus 4, that are the same. Because you are going to do that exact same thing. Now that both of my terms, technically right now 3x times x plus 4 is a term, and negative 2 times x plus 4 is a term, I can take out the factor. They both have the common factor of x plus 4 in them. So I can take that out right here. That's one of my factors. But now I'm only left with 3x minus 2. So this is the factored form of 3x squared plus 10x minus 8. Okay, on the next one, 8x squared minus 25x plus 3. In order to make it equivalent to what it was previously, I'm going to have an 8x squared. I'll have minus 24x I put there for you, so in order to make that equivalent to what it was above, it's going to have to be a minus 1x, or just a minus x, plus 3 is what it's equivalent to above. Taking the first two terms, 8x squared minus 24x, I can factor out an 8x out of that and be left with an x minus 3. On the next one, I could either factor out a 1 or a negative 1. I'm going to want to factor out a negative 1 because I want this to be an x minus 3 for my factor, not an x plus 3, because I want them to be the same. So once we have those factors, x plus 3, that are the same in each of our terms, you are now going to factor that out. That means like undistribute. So I'm going to undistribute that out, and what I'm left with is an 8x minus 1, or plus negative 1. You can just write it as minus 1, though. The next one, 6x squared plus x minus 2. 6x squared is the same as it was above, and now we don't know what the two x's in the middle are going to be, minus 2. So there's a couple of things that you could do, actually. In order to make one x, you could do negative 3x plus 2x, or other way around, sorry. 3x minus 2x. But there's a couple things that you need to be able to see in the patterns of why I chose the numbers from the first two problems to be what they were. So in this first problem, going back to, we'll do yellow, 12x plus a negative 2x, that adds to 10x, but 12 times a negative 2, that equals negative 24. And what else equals negative 24 in this problem is when we multiply 3 times negative 8. That also equals negative 24. Here in the second problem, we have negative 24 plus a negative 1x, negative 24 plus a negative 1x. And so those added together equals a negative 25, but when they're multiplied together, they equal positive 24. The first and the last term, or the highest degree term and the last term, the constant term, those multiply also to 24. So here we want to find two numbers where 6 times negative 2, which is negative 12, multiplies to negative 12. So we want two numbers that will multiply to negative 12, but add to a positive 1. And so that would be a 4 and a negative 3. And you can test that out. If it doesn't work in the end, then you probably just need to start over and try some new numbers. Okay, 6x squared plus 4x, we can take a 2x out of those, and we're left with a 3x plus 2. So we're going to factor out or undistribute a 2x. And then on the second term, we have negative 3x minus 2. We can factor out a negative 1, and that leaves us with two factors that are the same, 3x plus 2 on both terms. So we will factor those out, and what we're left with is 2x minus 1. Okay, on the next one, 6x squared minus 7x minus 20. 6x squared is the same as it was before, minus 7x minus 20. So 6x squared, or 6 times my negative 20. I'm trying to come up with two numbers that will multiply to negative 120, but add to negative 7. So give me a second here. Okay, so if you just test out some numbers with that, we can get that 8 times negative 15 will equal negative 120, and 8 plus negative 15 also equals negative 7. 8 plus negative 15 equals negative 7. So these two numbers add to there, but they also multiply to my leading term and my constant term. So taking the first two, 6x squared plus 8x, 2x divided out of those gives you 3x plus 4. And then on my second terms, I have negative 15x minus 20. So if you take out a 5 or a negative 5, I actually should have changed that. That's a plus. So that would be a 3x right there. So you still are left with 3x plus 4. And you are left over with 2x minus 5. Okay. This last one, 10x squared plus 36x plus 18. So 10x squared, and then two numbers that will multiply to 180, 10 times 18, but add to 36, so that's going to be a 30x, 30x, and a 6x will add to that. So then I'm going to take the first two terms, and actually it doesn't even matter where you put these two, it should come out the same if you didn't make any mistakes in between. So if it goes 6x plus 30x, it should come out the same. Oops. Okay, so I can take a 10x out of that, and so I'll be left with x plus 3. And from 6x plus 18, you can take a 6 out of that, so you'll be left with x plus 3. Taking out of those two terms in x plus 3, or factoring out, you are then left with 10x plus 6 left over, and that's your factored form of this. So some patterns. Let's see if we write it like this. Your A times C has to be your A times C have to be what your B1 times B2 is as well. So they have to multiply to those two numbers. But the B1 plus B2 has to equal your B. That means that when these are added, they have to be your middle term. But when the numbers are multiplied, they have to be the same as what A times C is. So it comes with more practice, but hopefully you see some of the patterns. Looking at 6x squared plus 19x plus 3, I'll do this one with you. We can look at 6x squared plus, I'm going to add something x plus something x plus 3. I know that 6 times 3 is 18, and 1 plus 18 is 19, but it also multiplies to 18. So I'm going to go 1x and 18x. I can take out an x from this and be left with 6x plus 1. And I can take out a 3 from this and be left with 6x plus 1. So one of my factors is 6x plus 1, and the other factor is x plus 3. So there you go. Practice that.